All right, so people are going to continue filtering in for a couple of minutes, but it's actually 11:40 right now, which I think means I'm officially allowed to start. So thanks for your comments on here. Oh, developer productivity has taken the win in the end. Brilliant. All right then, so this talk is this. And I should start by introducing myself. So hi, everyone. Thanks for coming. My name is Steve, and I work at Microsoft on the .NET team, and particularly been focusing for a few years on Blazor. And you are obviously wonderful people of great wisdom and good taste, since you've chosen to come into this talk. So I'm happy to be spending this time with you. During this talk, there's kind of two parts to it. We're going to spend the first 40 minutes or so focusing on Blazor and where we've recently been, where we're going in the future, where we might go a bit further out. And then for the last 20 minutes or so, we're going to change the focus to something a little bit more far-fetched and from the future and more experimental. But even though there's two separate parts to this talk, it's all part of a single unified timeline. So you can think of this talk as a bit of a journey through time, if you like. We're going to start with talking about what the current state of things is for Blazor developers, and then where we're going to head after that. So to get started, where we are with Blazor at the moment is we've just done our .NET 6 release. How many of you have used Blazor on .NET 6 yet? Ooh, that's like about a third of you. How many of you have used any other version of Blazor prior to that? Yeah, that's like 2/3 of you. All right, so there's still a third of you that haven't experienced this wonderful thing just yet. So .NET 6 is the most recent release of .NET. It came out in November last year. We do a major release every year, so that's not surprising. And we did a lot of work to improve things for Blazor in .NET 6. I'm going to demonstrate some of them for you. And in particular, I'm going to be focusing on the ways that we've made Blazor able to work now with an incredibly wide range of other technologies. So that will be a big emphasis as we go through this talk, the ability to use Blazor with just about anything else that you want to use. But not absolutely everything will be on that subject. So, for example, the biggest feature that we did a lot of work on in .NET 6 was hot reload. You probably know what that is, but in case you don't, it's the ability to edit your code and see the changes live in your browser without having to wait for recompiles, without having to restart your application, that sort of thing. I'll give you a demo of that in a minute. But one thing that we did do that is about working with other technologies is the ability, if you want to use your Blazor components, whether they're written with Blazor WebAssembly or Blazor Server, inside other technologies. So if you've got an Angular or a Vue or a React application, you want to use Blazor inside it, you can now do that. I'll show you how that works. We did a feature for Blazor WebAssembly, which is to pre-compile your .NET code to raw WebAssembly bytecode. Because normally, Blazor in the browser is running on the .NET interpreter. And if we do AOT compilation, we can make your code run 10 or 20 times faster at the cost of being bigger and taking longer to compile. But it's a good trade-off in a lot of cases. Speaking of app size, we made the smallest Blazor WebAssembly apps smaller. They used to be about 1.6 megabytes prior to .NET 6. But you can now strip out more stuff if you want. You can get it down to about 1 megabyte, which is obviously nice. We also added the ability to work with code written in other languages. So if you've got some libraries that are written in Go, Python, Rust, Swift, anything that can run on WebAssembly, you can now use that directly inside your Blazor WebAssembly applications. There's actually loads of other stuff that we did, which I'm not going to have time to go through one by one. And this is stuff that shipped already, so you can go and check out the release notes on GitHub if you want to. But I really want to show you some of this stuff. You don't want to see slides. I know you want to work with some code because you're mostly developers. So let's do some demos of some of this stuff. We're going to need a scenario. And the scenario we're going to have for many of the Blazor demos in this talk is a space agency, a fictional space agency called Blazorbital. And this is a company that you work for, imagine. You are a developer working for a space agency, and your job is to work within the manufacturing group. So there's various groups within this company. You work on the team that builds and designs things like rockets and space stations, that sort of thing. And you particularly work on the inventory management system, which sounds a bit less cool when you think about it. But hey, you still work for a space agency, so you can still feel good and look popular at parties. So we're going to start up this application, which we imagine that you've written using Blazor WebAssembly, and we're going to add some functionality to it. Now, first thing is we have to log in because, you know, it's all secure and highly locked down, so the backend servers won't talk to us if we don't log in, so we'll do that. And then this WebAssembly application will start making gRPC calls to a backend in order to get some data. It's got some stuff about what's going on in the warehouse, but we don't really care about that for the purposes of these examples. We're going to focus mostly on this inventory screen over here. Now, when I go over there, you see that it's starting to synchronize data from the backend server. That's all coming in over gRPC, and it's actually storing it in a client-side Sqlite database. So we've got Sqlite compiled to WebAssembly in the browser, and we'll talk about how that works in a minute. But the great benefit of doing this, of having all the data locally in the client, is that you can provide a really spectacular user experience. So even though we've got a lot of data here, we've got 100,000 items, I can just instantly scroll to any point in this list, and it just shows up straight away. We don't have to wait for responses to come back from the server. We can also do things like querying, and you can see that that's going to update as I type. We can obviously do things like sorting, and we can do filtering. And it's really nice how this sort of thing works. You can see as I scroll, it's just incredibly responsive. It's like 60 frames per second of querying there. So you wouldn't be able to do that if you were talking to a server all the time. So it's quite nice that we can do these kinds of things. Quite happy with it. But there are some things about this application that are not so great. For example, these ridiculous numbers over here. What on earth is this? Is that millions, billions, or what? Are we talking dollars, pounds? I don't know what's going on with these crazy price numbers. So let's fix that using the power of hot reload. And that is something that we did a lot of work on in .NET 6 and hopefully is going to make you more productive. So let's just see how this price number is implemented in our code. And I'm going to go into VS, and I'm going to find the specific Blazor component that is rendered there. Now, obviously, there's way too much code for you to read, so don't feel like you're under pressure to take all that in at once. All you really need to notice is that we've got a grid, and the source code for that grid is inside this repo. I'll give you a link to it later. And the way it's able to handle such a lot of data really fast is because it's a virtualized grid, so it's just rendering what's on the screen as you scroll. And there's various columns in there. The one that we're going to care about just now is this one that displays the price. And you can see it's displaying the price in cents, which explains these awful-looking numbers. So let's fix that, shall we? Let's make a small change to the code, and I'm going to move the IDE down here. And I'll say, OK, let's say, firstly, we want to display it in dollars. So I'm going to just divide by 100 like that, and I'm going to click on the Save button. And because of the glory and wonder of hot reload, just simply clicking that button should, in theory, cause the browser to update. And I don't lose my scroll position, my filtering conditions, or anything like that. I don't have to recompile. It just updates. Now, in case that was a bit subtle, let's change this a bit more. Let's change the column title to put $1 in, just so that people understand what that is. So I press Save, and then that is just going to show up again in the browser without me having to switch back. Maybe I want to change the alignment to right alignment, because it's a number. So again, I'm going to save that, and then it's going to jump over onto the right, just like that. And finally, I'd like to have some comma separators in the middle of there. So I can write some arbitrary C# stuff here. Let's use a number with 0 decimal places, and I'll press Save one more time. And now the commas are going to appear right in the middle of that number, right there. So we've managed to make that actually make sense, and we've had a really good developer experience as we went. Excuse me. So we didn't have to recompile, we didn't have to switch back to a browser. It was nice and fluid. Now, we don't support hot reloading every type of code change at the moment. We support more for Blazor Server than we do for Blazor WebAssembly, but we are working on closing that gap and increasing the amount of code changes that can be hot reloaded. In the case that you make a change that can't be hot reloaded, the system will detect that and it will automatically reload stuff in your browser. So you still don't have to manually recompile, but whether it's really fast or not so fast depends on what code changes you make. All right, so that's hot reload. But let's start talking about working with other technologies, since that's something we want to focus on a bit. Let's say that we want to use some libraries that are written with other languages that normally have got nothing to do with .NET or JavaScript. And the scenario for this is, let's go into one of these things. Let's go to the personal jetpack. That sounds fun. And in here, you'll see that this is meant to be a shipping label that people can print out and stick on stuff in a warehouse. And we're meant to have a QR code where this grey box is. So how can we render a QR code? Well, one way you could do it, obviously, is you could go and get a NuGet package that is implemented in .NET and renders QR codes. Or you can do it with JavaScript through JS Interop if you wanted to. But for the sake of this talk, let's imagine that for whatever reason, you are required to use a library that is implemented in a different language altogether, let's say Rust. Now, as it happens, I have got a Rust implementation of a QR code renderer over here. Okay, now I know a lot of you probably are not Rust developers. I'm not really a Rust developer, although I did manage to piece this together. And so just to give you a momentary overview, this is using a third-party crate or package called QR code, and that is going to render some data into a buffer, this array of bytes just there. And this is all exposed as a function called generate QR code. And we're going to want to call that from our Blazor code, which is running on WebAssembly inside a browser. It's not something you would have really been able to do in any reasonable way in the past. But let's try and do it right now, shall we? So first, we're going to have to compile this code. And I want to just move my windows around. To compile it, I'm going to use cargo build. That's Rust's normal build toolchain. And I've configured this project already so that when it builds, it produces a WebAssembly binary. So if you look over here, we've just generated librustqr, which targets Wasm32, which is WebAssembly. Okay? And now we're going to want to use that inside our .NET application. How can we do it? Well, actually, rather easily. And to do that, we have to first make a reference to that library that we just built. So I'm going to go into my project file here, and you can see at the bottom, we've now got this new thing called native file reference, and I'm using it to say, I want to make available in compilation librustqr, which we just built. And then we want to call it from our .NET code. So I'm going to go into a different Blazor component right now. This one is trying to render stuff into an HTML canvas. That's going to be the QR code. And it's going to render whatever is inside this buffer here, this byte array. And that is going to be populated by calling generate QR code, which we are importing from that DLL. So there's a bunch of things lined up together, and that will hopefully result in a call from our .NET code into Rust. So let's just check that out, shall we? I'm going to, again, rearrange my windows a little bit, like this. And then I will uncomment this line and press save. And hopefully, because of hot reload, that call into Rust will now go through, and we'll actually be rendering our QR code. And that's a real one which actually works, which is nice. OK, so that's an example of how you can make use of code written in other languages. This is also how we're using Sqlite here in the browser. Now, when I did a previous version of this talk, I had to show people how to compile Sqlite to WebAssembly, then how to add the native file reference, and how to add all of these DLL imports and different extern methods so you can call. Quite a lot of work. And you might think it would be nice if we could just have someone else do that for us. And the good news is you can. So this work can all be packaged in a NuGet package, which is exactly what has happened. So if you want to use Sqlite inside your Blazor WebAssembly app now, you can reference excuse me, this Sqlite PCL raw package, and that contains binaries of Sqlite for Windows, for Mac, for Linux, and as of a couple of months ago, also for WebAssembly. So just by referencing that, you get Sqlite. You can reference CF core, and that's also going to work, and that's just how we've got Sqlite there. So that's pretty nice. All right, next thing, improvements to JavaScript interop. We did an improvement in .NET 6, which means that when you are passing binary data or streams, we can do it in an efficient way now. Previously, everything was JSON serialized, but as of .NET 6, if you're working with binary data, we don't go through a serialization process. It makes it much faster, and I can show you that incredibly easily because we're doing it already in the code that we were just using. When we call this JavaScript method to populate the canvas with the buffer, we are passing this buffer here, which is a byte array, like that. So prior to .NET 6, that would have all been serialized and copied, which is not very efficient. But as of .NET 6, whether you're using Blazor Server or WebAssembly, we can now pass that data without serialization or copying. So that's a nice improvement. OK. Now, onto something a bit bigger and perhaps more interesting, I think it is. The ability to use Blazor components inside other languages and frameworks. So let's imagine that in your space agency, you're not the only division, okay? There's another division besides manufacturing called the missions team, right? These people work with the people who are actually in space performing their missions or whatever. And it's a different group of developers that supports that. And this other group has made some other technology choices. They've chosen to build an application using React. And I'll show you their React application just now. We won't go through all the code, but I'll just bring it up in a browser, okay? So here's missions control. It tracks where all the satellites are and things like, you know, how long since we last saw any aliens, just typical kind of space agency stuff like that. And it needs to talk to the same backend, so we'll have to log in. It's going to use the single sign-in system, so I don't have to enter my password again. But now I'm logged in, I can access all these other things to do with missions and things like that. And one day, the developers on this team, they come to you and say, hey, you know, while missions are happening in space, sometimes stuff goes wrong, believe it or not, and we need to get replacement parts. And we need to know where the parts are, like what warehouses they're in and stuff. And we've heard that you've made this really good inventory tracking system. We would like to have it in our application. Can we do that, please? So we've already added this page for you that just says to do. Please fill in your Blazor code here and make it work for us. So can we do that? Can we add a Blazor component into a React application? Well, the answer is obviously yes, otherwise I would not be raising this whole subject. That would be just making me look silly. So let's have a go at doing it, shall we? Let's move my screen around until I can actually see more than one thing at once. Okay. And we are going to have a look at what's in there. Still not in the right place. There we go. Right, so let's go into the React code for this equipment finder screen where we've got the to-do sign just there. And you can see that it's not doing very much right now. If you know React, you'll see this is very simple. If you don't, well, the only thing you need to know is it's keeping track of some search text, which has been entered into a box up here. And then at the bottom, it just says to do. So how can we bring a Blazor component in here? Well, one way that we could have done it historically, that's always worked, is just to put a big iframe in the page here in which we can load a separate application. And, you know, that's going to work, but it's kind of rubbish because it wouldn't integrate properly. It wouldn't share any authentication state. It wouldn't share the styling, and it would be really hard to get data into it or data back out. So wouldn't it be a lot nicer if we could just use our Blazor components as if they were normal HTML elements? And that is what is now supported. So if I'll show you how we do this, if I go into my Blazor WebAssembly startup here, and this is not a WebAssembly specific feature, by the way. You can do this just as well with Blazor Server as with WebAssembly. You can say, take one of the components that you've implemented, for example, the inventory, and register it as a custom element with a particular name, in this case, inventory grid. And then, as long as you've added the necessary script tags to your other application, you can use that just as an HTML element. So I'm going to add an inventory grid right here. I'll press save, and then React's hot reload system will kick in, and we should now see our Blazor component show up here inside React. And it's got all the behaviors that we expect, you know, it's all the sorting and filtering. It's all going to work, so that's nice. But I don't really like the style of it very much. I don't like the fact that it uses this light theme when everything else uses a dark theme. Can we change it? Well, one of the nice things about the fact that this is not an iframe, it's just normal HTML structure, is that we can use normal CSS to style it. So here, inside my React application, I'm going to find the inventory grid table, and I'm going to apply a filter to say invert 1, and then instant dark mode. So that's nice. That's going to keep our astronauts a bit happier. What else? What about being able to search? So you see as I'm typing here, it's not doing anything. That's because I haven't done anything to wire the search up. Now, the Blazor component takes a normal Blazor parameter called search name, and I can pass that as an HTML attribute. So I'll press save on that, and now you'll see my search has been applied, and as I type, again, it's all just going to update as I type, which is pretty nice integration there between React and .NET. And you may have noticed that when I've made changes here, React's hot reload system has been working. But what about .NET's hot reload system? If I edit the .NET code, is that going to update even when it's running inside React? Well, let's try it, shall we? Let's go back to the code for this inventory grid here. And I'm going to make a completely arbitrary and otherwise pointless change where I'm going to change the column title. You see where it says category there? Well, here's the code for that. Let's just change it to cat name. And then I'm going to press save. And when I do so, we should see inside the React application, that category name should, all being well, but apparently, oh, there we go. Things are a bit slow today, but it did indeed update. So we've got React's hot reload system and Blazor's hot reload system working together in the same application simultaneously, making you pretty productive and able to share your code really well. All right. So that's enough of the .NET 6 features. Let's now turn our attention to what's going to be happening in the future, or in the very near future. And the next major way in which you'll be able to use your Blazor components with a wider range of technologies is the ability to take them beyond web browsers and into native applications. So that is a feature that is going to ship in the well, now-ish, like we're in Q2 2022 already, and this project, .NET MAUI, is poised to ship incredibly soon. And one of the cool things we can do with that is use Blazor with it. So you might know what MAUI is already, but just in case you don't, very quick overview. It stands for Multi-Platform App UI, and it is a system by which you can build and deploy cross-platform native UI applications with .NET from a single code base and target Windows, iOS, Android, and Mac. It is, behind the scenes, a major evolution of what used to be called WPF. We've done tons of work to make it into a really first-class part of .NET now, which is why it's been granted a whole new name, and it's got a lot more people working on it, and it's got a lot more investment. So that's all very nice, but what's really nice if you're a Blazor developer is that one of the things you can do with MAUI is you can do a Blazor inside it. And the point of doing that is you can now reuse the same components that you ship for the web inside native applications across all of these platforms. And of course, you can still make use of the native functionality within each of those platforms. So let me give you a quick example of doing that. We'll go back into our solution here, and we'll imagine that for whatever business need, we want to make our inventory tracking system into a native app, for example, so that the warehouse workers can walk around with it on iPads or whatever else, I don't know. And we want to share our existing code from the web with this native application. So what's the best way of sharing code? Well, one way that I think works particularly well is to just factor it all out into a reusable library. And that's what we're doing here. So you'll notice I've got this manufacturing hub project here, and that is the Blazor WebAssembly application, but it contains almost no implementation at all, because the implementation for all those components and even all the static content that we're using is inside this separate class library, which I've called Manufacturing Hub Core. And the fact that it's in this separate library means we can easily import that and use it inside a MAUI project if we want. And in fact, I've got a MAUI project down here, the one that's called Native App. I'm just going to set that as startup there. Now, if you haven't seen MAUI before, it's a nice single project system that targets many platforms from a single project, and you can configure various things for each of the targeted platforms from that one project. And then you can define the native UI for it using XAML. So it's a special flavor of XAML that's specific to MAUI. And one of the things you can do inside that MAUI XAML is to have a Blazor web view. And this is how we can introduce our Blazor components into our native app. You just have to say which Blazor component you want to render. And you could render an individual component on a fine-grained basis, or you can just literally dump your entire application right in there. And that's what I'm doing right now. I've taken the root component for the whole application and just put it inside a MAUI window. So let's start that up, shall we? So I'm going to start running it initially on Windows. And this is going to use the latest WinUI 3 technology, so it can do a lot of modern Windows things. And when that pops up, we should see that it looks and behaves more or less the same as what we had before. My machine is being abnormally slow right now, but here it comes. Slowly, there we go. All right, so it's the same thing that we had before, but now inside a native window. And it's going to have all the same behaviors and functionality that we've seen all along, which is all very good. What you need to make sure that you understand here, though, is that this is not using WebAssembly. Okay, this is not Blazor WebAssembly, it's not Blazor Server either. It's a new hosting model for Blazor, which is running directly on the native .NET code inside this application and rendering it into a web view. So that's nice. Now, I know some of you are probably thinking, so what? Like, we've been able to do this for years already. Like, have you heard of Electron? It's a way of rendering web UI inside a native frame. And that is absolutely true. So in many ways, that is similar to what Electron does, but there's two main ways that MAUI goes beyond what is possible with Electron. One of them is that it targets a wider range of platforms, such as mobile as well as desktop. But the other, perhaps more important way, is that it allows you to use whatever combination of web and native UI that you want. So in Electron, you're basically just using web UI with some small exceptions. But with MAUI, you can have as much native UI as you want. To give you an example of that, let's imagine that we don't want to have this web-based navigation system up here. But instead, we want to have some native navigation that matches the look and feel of each platform that it runs on. We can do that pretty easily. So I'm going to go back into my code here. And I'm going to say, instead of this content page right here, I'm going to replace that with a tabbed page containing a content page. And inside that, I'm just going to put the dashboard. OK, so we'll have a bit of native UI now that, well, I don't have hot reload for MAUI in this build of VS that I'm using here. I think the next preview may well have it, but this build does not. So I have to manually restart. And when that comes up, you'll see we now, what did I do? I must have killed it. All right, so when that comes back up, we will have our native navigation UI with our Blazor rendered dashboard inside it. There it is. OK, good. Right, so we've got our dashboard rendered inside this tab here. Let's add some other native tabs for different parts of our application. I'm going to drop in some more content pages. There's a bit of repetition here. You could factor that out if you want. But each one of these is rendering a different Blazor root component. So now we will hopefully have a complete and working native navigation system. So where's my application? There it is. All right. So now we've got these 4 tabs, and you can see that they behave in a nice sort of Windowsy manner. And they look like Windows tabs because they are native Windows tabs, and everything behaves as it should. And if we deploy this to other platforms, it's going to match the look and feel of those other platforms. To show you that, let me show you what this thing looks like if we run it on Android. So I've got an Android emulator down here, which I'm going to start up. It takes a moment to wake up. And when that does wake up, we should see that the web-rendered UI looks exactly the same on this platform as it does on any other platform, but the native UI matches the look and feel for Android. Okay, so I can switch over onto this inventory tab, and that works. But you can see it looks different. It looks Androidy, and it also behaves Androidy, like it does this sort of slidey thing as you move around, which I'm not sure that I like very much. But you know, it does do that because that's the way of things on this platform. So that's cool. All right, and of course we can deploy to other platforms as well, such as iOS and macOS. And I don't actually have a Mac here to show you that, but I did pre-record a video of this same application running on an iPad and on an iPhone. And you can see that once again, the web-rendered UI looks exactly the same, because why wouldn't it? And the native UI matches the style of the platform. So on iOS, you'll see the tabs show up at the bottom. That's just the way things are on iOS. So that's all very nice. Now, before we move on, I want to just pause for a moment and make sure that I'm giving you a realistic expectation of the degree of difficulty and power involved in this, because I'm slightly worried that I'm making it look as if like everything just works everywhere and it's effortless and you become a god. Well, that's, you know, kind of the true-ish, but actually there are lots of difficulties along the way with doing this, and I want to be realistic about that. So each time you come to deploying a new platform, you will find platform-specific differences and challenges. When I tried to deploy this to Android at first, I was getting some weird errors, which turned out to be because it was trying to store the Sqlite database in a place that Android does not allow. So I had to debug and fix that. And when I deployed to iOS, I got a number of weird styling issues, which I actually haven't fixed, so you can see them up here. One thing you might notice when it goes onto the grid and it starts scrolling it upwards is that some text will weirdly appear at the top of the screen on the status bar, which you'll be able to see about now. Yeah, well, that's because the status bar is translucent, and I need to fix that. You'll also notice that on iPhone, there should be some icons on those tabs, and I haven't put any icons there. That's because I developed it for Windows, and I didn't know that there should be icons, so I didn't put any there. So my point that I'm making to you is not that this is terrible or anything. It's just that you need to have the expectation that you will have to test on each platform, and you will find some issues that make sense and other issues that don't make sense, but nonetheless, you will be able to get through it. Once you've done all that, the payoff from this is that you can use your Blazor components with an incredibly wide range of technologies. So we've just seen that you can use them on a Windows native application, a Mac, on iOS, on Android, and of course, you can still use them on web, as you've always been able to, whether you're running inside the browser on WebAssembly or on Blazor server. But that's not all. There's even more, because we know that people still have yet more types of applications than this, particularly applications that have been around for a little while. So as part of the same release, we are also adding support for running your same Blazor components on Windows Forms and WPF applications, which might be a really nice way for you to modernize existing software properties. So to give you an example of that, let's imagine that yet again there is another department within your space agency. Besides the missions and the manufacturing groups, there's also the accountants. And you want to keep the accountants happy because they control whether you get paid or not. And they've got an application which, in this case, is written in WPF. All right, so maybe it's a legacy application, maybe not, I don't know. WPF is still a technology you can use. And if you know WPF, you'll know that it also uses XAML as its programming language. And inside one of my XAML files here, you'll see I'm using Blazor WebView. So just in the same way that you can use Blazor WebView inside MAUI, you can also use it inside WPF. And there's equivalently a Windows Forms control, so you can use it there as well. So that's pretty cool. Let's see this working, shall we? And we'll see whether the accountants will be able to keep track of what's in stock in all the different warehouses, so they can bill people for it or whatever. So when that comes up, it's going to do all this boring accounting stuff, and we go over onto the inventory screen, and then yet again, we should see the same application that we've been building. Oh, it makes me log in because it's trying to synchronize stuff with the back end, even though there's no changes, so that doesn't help us. But anyway, I've done that, and that really is the same code that we've just been working on. You can see it's got the cat name thing just there because, that's the latest version of that code. And it's going to have, again, all the same behaviors as before. One slightly interesting thing to point out at this point, though, a little bit of a puzzle for you. If I go into this pentagonal stub, whatever that is, you'll see that it's got a QR code rendered there. Now that, if you think about it, might be a bit of a surprise because we compiled that library to WebAssembly, and this is not a WebAssembly application. This is a native Windows application, and there is no WebAssembly in this at all. So how is that QR code showing up? Well, the answer is that I was being slightly devious and secretive before, because when I said that I compiled it to WebAssembly, I was also compiling a native Windows binary for the same library in the background. And then the fact that we load it using this, what's it called? DLL import, well, that's the same syntax that .NET has always used for loading native code from DLLs. So if there's a native Windows binary for this, it will get loaded and run inside our Windows application. And similarly, you could compile a native binary for Android, iOS, and so on if you wanted to. So you can continue to share all these parts of your code across all platforms. So that's pretty nice. All right, now let's take another step forwards in time to where we're going to go with Blazor next. And the next major release for Blazor is going to be part of the .NET 7 release, which is scheduled for November this year, which should not be a surprise to anyone since we do major releases of .NET in November every year. And again, we've got quite a lot of plans for how we can improve Blazor in .NET 7. I won't actually be able to demonstrate them to you, however, because we haven't implemented these yet. We've been so focused on MAUI, but we are starting and have started in pretty much the last week on really focusing on this part of the product now. So to give you a quick overview of what we've got as candidate features on the roadmap, I have actually kind of shown this thing to you already. When we added the inventory grid to the React application, 98% of what I was using there is stuff that is shipped in .NET 6, but one tiny bit of it is actually not shipped yet, and that will be included in .NET 7 for custom elements. We are looking at adding multi-threading to the WebAssembly runtime because modern browsers now have the ability to do multi-threaded WebAssembly code, so we want to bring that to Blazor as well. We've got lots of plans to improve the performance, the reliability, and the feature set inside the Razor editor. So you can be looking out for some cool new stuff going on there. One thing that I think a lot of people will like, and I certainly will like, is the ability to create a Blazor project that does not include a counter and a silly weather forecast page. So yeah, that's definitely going to be a popular one and very cheap for us to do. Hot reload, like I said before, it doesn't support every possible type of code edit today, but we're going to increase the range of code changes that are supported. Currently, it's not supported to have multiple Blazor applications in the same web page at once, but we are looking at adding that because we've got some important customers that have told us that they need that feature. We are considering adding a basic grid into the box as well. So you saw that grid that I was using with Blazor Orbital there. Well, of course, there are many grids that are already available for Blazor, whether it's open source or third-party component vendor type things, and we're not trying to replace those, but we are considering adding a very basic, lightweight, and highly performant starting point for grids inside the box so that people can build their own stuff on top of that. That one's too boring to talk about. Web crypto. So when you do crypto at the moment with Blazor WebAssembly, there's quite a lot of .NET code that gets run. We're looking at mapping all that into JavaScript so that it can use the browser's built-in native crypto features. And we're also looking at improving AOT support so that instead of AOT compiling everything in your application, you can selectively compile just the individual bits that need the most performance gains so that you don't have to wait for the pre-compilation process for everything else and to keep your app size small. So, like I said, it's not implemented yet. If you go to the URL at the bottom there, the roadmap, then we would love to have your upvotes or your downvotes or your snarky comments or whatever else you've got to say about these features, and you can influence the process of what we actually build over the next few months. All right, but let's move on from that and talk about something a little bit more futuristic, about ways of taking .NET into whole new places and working with entirely new kinds of technology. Okay, and this is not about Blazor. It is about WebAssembly, but it's actually about WebAssembly on the server. And to understand why that's relevant, what that even means and why you would want to do it, we'll take a quick step back to understand what WebAssembly itself actually is. So even if you've been using this, you might not have a completely clear mental picture of what WebAssembly actually is. Well, it's been around for about 7 years now. It's quite a well-established technology. And what it actually is a bytecode format, a way of representing instructions that are independent of any particular operating system or CPU architecture. And it's designed, first and foremost, to work inside a sandbox because, of course, it's originally designed to work in browsers where you often face hostile code. So that sandbox needs to be incredibly rigorous and bulletproof and trustworthy. And that's what WebAssembly always has been. Like we don't see sandbox escapes with WebAssembly. Now, in order to make it that robust, it's got a very minimal feature set. The only thing that WebAssembly bytecode can do natively is just perform operations on its own memory, just changes numbers in its own memory space, which might seem entirely pointless. And it would be if there was no way of interacting with the outside world. And so the way of interacting is by importing and exporting functions. The host, such as the browser, can supply functions into the WebAssembly code that it can execute, and WebAssembly code can export functions that the host can call. So that's how that interop with the outside world actually works. Now, imagine you want to use this as a server-side technology. We'll talk about why in a minute, but just imagine you do. You're going to want to interact with operating system features somehow. And to do that, the best way to model it would be by importing some functions for those operating system features. But what functions would we import? And could there be some kind of standard to say what it looks like? Well, that is what WASI is. WASI, WebAssembly System Interface, is a spec that's been around for a few years now from Mozilla, and it defines a standard set of imports of operating system-like functions. So if you want to work with a file system or open a network socket or whatever, WASI has functions that it's got a definition for the functions you can use. Now, it's still designed to be run in a rigorously sandboxed way. So just because there are some functions for working with file system, for example, doesn't mean that you're allowed to use them. The host chooses what functions to give you access to, which is how it can protect itself. And like I've been saying, this is not about running in a browser. This is not about using any kind of JavaScript-based runtime. It's about running in a very lightweight and contained server-side environment. But what's the point? You can already run server-side code. You don't need WebAssembly to do that. Why would you want to use WebAssembly on the server? Well, there are many ways you can think about this, and people describe it in different ways. But one way that I think is useful to think of it is that WASI can act as a universal application binary interface, Well, that is a contract between a host and some code that runs in that host. And this host, it could be a cloud service. It could be something that runs at the edge of the cloud, like a CDN or some kind of low-powered IoT device. It could be a plugin model for some software, like, say, an Office plugin, or it could be a flight simulator or a music studio plugin or something like that, or maybe a programmable feature of your operating system. And then the code that you're running in there is obviously just whatever code you, the developer, choose to implement. And the benefits of having WASI be the ABI, well, there are benefits on both sides of the equation. For example, on the host side, it means that the code that is being executed is sandboxed, which is great if that code turns out to be malicious, but more likely the code is not malicious, but it just accidentally contains some kind of security vulnerability. Well, the fact that it's sandboxed means the host is still defended, even against unintentional vulnerabilities like that. And it means the host can choose exactly what capabilities it offers to the code. Can it access file system? Can it access network? Things like that. And even beyond that, it can decide how much CPU time is a given call allowed to take up? How much memory are you allowed to allocate? So the host can very, very completely defend itself against whatever type of code is running inside it. And there are other benefits too, such as the ability to simplify the developer experience. You can work with any build toolchain. You just have to take a single Wasm file for deployment. So that's nice. And then on the application side, benefits include that you can use any programming language as long as it compiles to WebAssembly, which is, most of them these days. And then when you come to deploy, you don't have to care what the operating system is that you're deploying to, or even what CPU architecture it is, because the same binary will work universally across all operating systems and all CPU architectures. And by the nature of WebAssembly, which has always been about JIT compiling to nearly native speed code, at runtime, you should be able to get excellent performance. So in a way, this could look like a major evolution of containerization on the server. And some people have said that this will be the future of server cloud-native containerization. And we don't know whether that's true. Maybe it is true. Maybe WASI is going to take over the industry. Maybe it's not. We don't know. But what we do know, at least what we goal is on the .NET team, is that we are going to try and keep you at the forefront of wherever the industry goes. So if WASI takes over the industry, .NET is going to be able to go there. And you as .NET developers are going to find that your skills and your existing code can move to wherever the industry goes. That's our objective with what we're doing around WASI right now. So let's think about running .NET in one of these kind of environments. How do you compile to it? Well, you might think, well, we can already compile our .NET code in such a way that it runs on WebAssembly. That's Blazor WebAssembly. Have you heard of it? And the truth is, yes, of course you can do that. But unfortunately, that is not going to work in a WASI environment. Okay, the existing toolchain will not work. And to understand why, let's talk about what it does. So the toolchain we use for compiling Blazor WebAssembly is called Emscripten. It's been around for a while, and it's designed for running code inside a browser. So when you compile your project, what comes out of the compilation process is, well, the .NET runtime, which is pre-compiled to a WebAssembly binary, and we've already compiled that for you. Obviously, you also get all your .NET DLLs produced by the C# compiler in the normal way for your code and anything else that you rely on. And then finally, you get some JavaScript, which knows how to start this stuff up inside a browser. And then when your code is running, when you use some kind of call to an OS feature, that eventually translates into a call into JavaScript. And that's what Emscripten gives us. It's this mapping of features into JavaScript. So that's great when you're in a browser. It's good that we split stuff up into lots of files because the download can be parallelized. And it's good that we're using JavaScript because, that's what's in a browser. So that makes sense. But in a WASI environment, this is not good at all. It's not good that we split stuff up into lots of files because that's really inconvenient to deploy. And sometimes it's actually impossible because some WASI environments only allow you to give them a single Wasm file. And it's certainly not good that we're running on JavaScript because there is no JavaScript. So it's obviously not going to work. Which is why we started a new experiment with a new way to compile .NET to WebAssembly using the WASI toolchain, which is built on LLVM. And when you use this, the output from the compilation process is just a single WebAssembly file, which contains everything that you need. It's the relevant parts of the .NET runtime, it's your .NET code, and it's any other files that you rely on, all in that one file. And when you call OS features, it's not going to use JavaScript, it's going to use the system interface functions defined by WASI, so it can run anywhere. So let me show you this experimental new compilation mechanism. I'll go into a command prompt, And we're going to start by making the simplest thing we possibly can. So the simplest thing that I know of that exists in the universe is a console project. Okay, and we're going to go in there, cd hello WASI, and I'll just .NET run that. Now, obviously, this is not WebAssembly yet. This is just plain .NET that we know and love, and it just prints out hello world. In fact, to get a bit more info, let's make it print out slightly more stuff. So I'm going to just copy a bit of code that I've already prepared, and we are now going to make it display the current time in UTC and the architecture of the CPU that I'm running on. Okay, so go back and I'll .NET run that again, and now it's going to display a slightly different output. Here's the time in UTC, and here is the architecture of the CPU in this laptop. Cool. But how can we run it on WebAssembly? Well, we can use this experimental new SDK called WASI SDK. It's on NuGet. You can try it out yourself if you want to. And when you've got that, next time you do a build, you still have to be able to type, sadly, then some slightly different stuff will happen. So let's see. So it still compiles your .NET code to a .NET DLL in the normal way, but that won't actually be used at runtime. What is used at runtime is the result from bundling all these DLLs that we depend on and the relevant parts of the .NET runtime into a single Wasm binary, which will pop up here, hello WASI.wasm. So that is now the whole application. In fact, I'm going to just show you, if I build that another time, it will go through a bit faster because it doesn't have to do that bundling process every time. So it's, nice and fast and incremental. Okay, so here's our file that we generated. How can we run it? Well, there are various server-side WebAssembly runners available which support WASI. And the one I'm going to start with is one called Wasmtime. It's an open source project. It's built by the Bytecode Alliance, which is a group of companies that includes Microsoft, Google, and some others. So this is a well-engineered runtime designed to run your WebAssembly on the server. And I can use it with this binary that we just built. So actually, it's called Wasmtime. And when I run that, you'll see exactly the same output that we had before, except now the CPU architecture, as far as it's concerned, is WebAssembly. And that is a big step forwards. But what's actually going on inside here? What is in this file? And how do we know if it's really compliant with the WASI spec? Well, let me show you. If I have a look what's inside that file, I'm going to list all the imports. Remember I said that WebAssembly imports and exports functions? Well, let's see what functions are being imported by that file. You'll see there's 23 functions that are imported, and it's stuff to do with, file system access and clock and other stuff. You don't need to read the list. All you need to notice is that every single thing in that list is part of the WASI Snapshot Preview 1 namespace. So these are all WASI standard compliant functions. We don't use anything that's not WASI, which means that we can run in any WASI environment. And just to check that, let's try a different runtime. This one's called Wasm. It's built by a different third-party group. It's also open source. And if I try to run the same binary in there, you'll see again, it runs, produces exactly the same kind of output. And you should expect that because this is all standards compliant stuff. So that's nice. But we haven't done very much so far. All we've done is just printed hello world to a console. If you're going to work with these technologies, you probably are trying to build some kind of new network-enabled software. Because after all, this is the future of the cloud, and that's what people are saying. So can we build some kind of cloud service in .NET and run it in a WASI environment? Well, that would probably, if you're a .NET developer, mean running ASP.NET Core on top of WebAssembly. Can we do that? Well, let's check in a different example. So I've got a very, very simple ASP.NET Core application here, just about the simplest thing we can possibly do. For every single request, it's just going to reply, hello, this is your operating system architecture, which really means CPU architecture. Don't know why it's called that. And it says completely standard ASP.NET Core stuff, except for that. This extension method up here, this means I don't want to use the normal Windows or Linux network APIs. I want to use the network APIs that are provided by WASI. And as for where that comes from, well, that comes from this package, WASI ASP.NET Core Server Native, which is part of this experimental group of SDK packages, which I've added. Obviously, I've also added the WASI SDK because I want this thing to build to a WebAssembly file. And I've also added a few parameters that tell the host which TCP ports I want it to be allowed to listen on. So this is set up to just build with .NET Run or F5, Control F5. So I'm going to do a Control F5 right now. And when that pops up, you should see that that comes up in a browser. And we do indeed get the message from ASP.NET Core, which is now actually running on WebAssembly. And if we look at the native binary that's running there, you'll see the actual native executable here is Wasmtime that we are running inside. So that's pretty good. But it's still boring, isn't it? It's still just the web equivalent of printing hello world to console. Can we do something a bit more interesting, please? Can we use some of the more advanced features of ASP.NET Core inside this kind of environment? Well, to prove that we can, I've got yet another project over here. This is called ASP.NET Core Features, and this is basically what you get when you create a new ASP.NET Core application, except that I've also added a few extra things into it. And this is also set to compile to WebAssembly and run on Wasmtime, just so that we can verify that these other features actually work. So I'm starting that up now, and you'll see again, this is running inside Wasmtime right there. All the console output is coming out in the way you'd expect. And in the browser, we are now doing very normal ASP.NET Core stuff. So we executed an MVC controller. It's rendering a Razor view. We've also got an example showing that Razor Pages is going to work there with some static content inside it. We've also got an example of a minimal API, which just tells you what the time is. If you want to see the code for that, well, very simple stuff. Here's the minimal API right there. So it's just normal ASP.NET Core stuff. We've also got gRPC in there. Now, I don't know if you've seen gRPC running on WASI before. I hadn't before I did this, but it was extremely simple to just enable because all the existing code still worked. So if I want to call this greeter service here, which, this is the kind of the classic example of gRPC that just replies hello to each call that comes in. If I want to call it, I'm going to need some external code that can make a gRPC call. So I've got this command line application over here called greeter client, which I will run, and you'll see it does the gRPC call there, which hits this endpoint inside ASP.NET Core, which in turn is running on a WASI runner. And that works, that's nice. And then finally, we've got an example of doing SignalR on WebSockets, which again is not something that I'd seen working on these technologies before, but the existing .NET code just works. So the normal way that we do an example of something like this is we have two windows, and let's type something in. Hey there, you on WASI. And then we hit send, and you'll see that the same message shows up in both browser windows because they're both connected to the same WebSocket endpoint. So the point of this really is that existing code and existing patterns can continue to work. Now, in another sense, that's also not the point, because if you just want to write the same kind of applications that you already do, you don't really need WASI to help you with that. The point of this is to be able to run your code in new kinds of places and maybe to explore some new kinds of application architectures. And I'm going to show you an example of that in 5 minutes or something. But just before we get to that, I want to show you a really bizarre example of something that you absolutely should not do and should never want to do, and you didn't hear it from me, okay? But I just find this kind of amusing, so I want to show it to you anyway, even though it's terrible. Right, so I've got another example application over here. And if I go in there, it's a boring like to-do list type thing. We've all seen to-do list applications. But the important point is, this is not Blazor. It's not any kind of JavaScript framework. All of the UI here is going to be just traditional server rendering. So the server renders some HTML, and then the browser is going to do a form post back in order to modify the state of the application. So traditional server rendered application. Where can we run a traditional server rendered application? Can we run it, for example, on GitHub Pages? Well, the answer to that would traditionally be no. Of course you can't run it on GitHub Pages. That's just a static file server. You can't do server rendered content there. Let's see about that, shall we? So I'm going to get the URL for something that I've already deployed. I'm going to go in my browser, and you'll see that this very much is on GitHub Pages. It's a real URL. You can go to it in your phone or whatever if you want to. And when I go to this URL, you'll see it says starting ASP.NET Core server up. And then after a moment, our actual application renders on GitHub Pages, and we can go in and we can start doing stuff, do stuff like that. And we can, start mutating the state of the server. We can have multiple browser tabs if we want to, and they're all going to share state. So you see the do stuff shows up there. We can go to this JSON API, and that's also got the same thing in. So how is this happening? What is the dark magic behind this? Well, if you can read fairly quickly, you might have seen it already. The magic trick is that this is not running on the server. This is running inside the browser. And to really prove that, if I go into the browser console here, you'll see all the ASP.NET Core console output is just getting spewed out into the browser there. So it actually works. Now, this is, of course, a terrible thing to do because it gives up on most of the benefits of server-side programming, but it is possible. And I'm only showing you just to give you a sense of the kind of power and flexibility we get. Now we've got this toolchain for compiling ASP.NET Core into a single standard compliant WebAssembly binary. And you know something that's famous for running WebAssembly is, of course, browsers. So that is how we can now run ASP.NET Core, the server, inside your browser if you want to, which you don't. OK, now, just in case you were confused about how this actually handles the network requests and so on, what I was doing there, when you go to this URL, it registers a service worker, and the ASP.NET Core application is running inside that service worker in the browser. So whenever there's any tab that tries to make an HTTP request to anything within that part of the URL space, it gets intercepted by the service worker, which then pushes the whole request through the ASP.NET Core pipeline, which is there in WebAssembly, and then just gives the HTML back to the browser. So it never even hits the network at all, which is why it doesn't matter whether we're on GitHub Pages or anywhere else. We just have to be able to serve this WebAssembly file in the first place. And if you've got multiple tabs, they'll be talking to the same service worker, which is how they're able to share state within your browser, but they will not be sharing the state with your neighbor's browser. So that's how that works. OK, so if that's an example of something that you shouldn't do, you're probably wondering, well, what is an example of something that I should do then? What are the real use cases for this sort of thing? And to give you examples of that, I will list some examples. There's a lot of industry momentum at the moment around WASI. You'll see a lot of open source projects, a lot of startups that are trying to carve out their space within this exciting new WASI world. And I think you'll probably see a lot more noise around that over the next year or two. Some examples of existing things. There's a startup called Suborbital, and they've got a multiple number of open source projects that are designed for running things around WASI. And I'm going to show you an example of that in a minute, so we'll come back to that. Wasm Cloud is another open source project. This is trying to do something a bit like Kubernetes, but instead of having a collection of Docker containers, you have a cluster of WASI-compliant modules that are running there. So that is potentially a lot more lightweight than the traditional Kubernetes experience. There's also Envoy. This is the proxy, which is often used in service mesh architectures. Often it's used with Kubernetes. And Envoy has got a plugin mechanism which allows you to supply WebAssembly code. So now it's possible to run ASP.NET Core inside Envoy if you want to. And we actually do have some use cases for doing that. So that's nice. Fermion, another startup that are building a bunch of open source projects about that. Probably best if you just go to their website if you want to learn more about what they're actually offering. Lunatic is an attempt to recreate something a bit like the Erlang Beam virtual machine. So it's an actor model system. And this allows you, instead of just deploying a single WebAssembly module instance to run your application, you will have tens, hundreds, or hundreds of thousands of instances all working together, implementing tiny bits of your application, which is designed to give you incredible levels of scale and reliability. And then finally, we must not forget, of course, lest we be fired, Microsoft Azure now supports WebAssembly workloads as part of the Azure Kubernetes service. And you may well see more from Azure on this subject in the future. So just to finish this off, I want to show you one of Suborbital's things and how we can work with it. Suborbital has got a runner for WebAssembly called SAT. And SAT is meant to be the most tiny, lightweight, and fast way of running your WebAssembly code. It's designed to run on, say, like low-powered devices or inside a CDN or that kind of thing. And I want to show you that ASP.NET Core can run inside there as well. Now, this is not a visually spectacular demo. It may seem, in fact, that nothing interesting happens at all, and you'll wonder why I included it. But it's because I really want you to see that the end-to-end picture actually does work. So I've got an ASP.NET Core application here. It's just got these two endpoints. One is for storing a value with a particular key, and the other is for retrieving the value. And what this is going to do is run inside SAT, but more importantly, it makes use of the specific services that SAT offers. So SAT doesn't just run WebAssembly, it also gives you services like key value storage, GraphQL querying, or other things that you would use to build a real application. And I just want to show you that we can, in fact, integrate with all that. So if I start this running now, then when that comes up, that should not be running inside Wasmtime. It should be running inside SAT. You can see that right there, OK? And I can now make HTTP requests into that. as long as I've got my ready-made command. All right, so I'm going to use curl, and I'm going to say we'll make a request with event name as the key and the value as NDC London. Okay, so we get a 200 OK. That's coming back from our ASP.NET Core code, and then I can do the same request a second time, this time with just the key, and you'll see the value comes back as NDC London. So just as I promised, it's not spectacular at all, but it does go to show that by being compliant with all these standards, your existing ASP.NET Core code can run in an entirely new type of runner, which runs on different kinds of devices, and you can integrate with the services that it provides. So that's all we're going to have time to talk about today. If you want to try out any of this stuff, it would be really great. I would love it if you would give your feedback. So if you want to try out the Blazor Orbital app that we were using in a lot of these demos, you can find the source code for that at this URL. And if you want to get started with .NET on WASI, you can go to this URL, and that's where the actual SDK is implemented. But more importantly, it is also where you'll find instructions for how to start it yourself. Now, I must caution you with great emphasis that this is not a committed product, the .NET on WASI thing. This is just an experiment. We're simply getting started, seeing where the industry goes, seeing what customers tell us, seeing what kind of feedback we get. So I would love your feedback about anything to do with .NET on WASI and what you've tried. But other than that, I think we've run out of time. So thank you for coming, and I hope you have a really lovely rest of day. Remember to evaluate as you go out, and yeah, that's all. So thank you.